In this video, we're going to look at quadratic functions and applications of quadratic functions. We are first going to look at standard form of a quadratic function and then also look at vertex form of a quadratic function, and then we're going to look at how to actually graph a quadratic function when you have the vertex form provided for you. So looking at this, we're looking at the graph of a quadratic function written in vertex form. So the graph of a quadratic function is typically written as f of x equals ax squared plus bx plus c, where a is not equal to 0. And we end up getting a parabola as our graph. A parabola is just a U-shaped function, either pointing upwards when a is greater than 0, or it points downwards when the a is less than 0. So positive a values gives us a upwards facing u, and a negative a value will give us a downwards facing u. If a is equal to 0, then we have no x squared part of our function, and so then we are left with just a linear function. So it's really important that we're looking at functions that have a leading coefficient of a rational number other than 0 for our coefficient on the x squared value. The function may be written in vertex form as f of x equals a times the quantity x minus h squared plus k, and that gives us our vertex h k as a coordinate pair, and that gives us this value at the very minimum or maximum of our function, depending on whether our a value is positive or not. So the vertex form is very helpful because it actually gives us the numerical value and the coordinate pair assigned to our vertex or maximum or minimum of our quadratic function. Every parabola is symmetric over a certain axis of symmetry, and that axis of symmetry is equal to the vertical line x equals h. So I'm going to draw a dotted line through our parabolas to represent that axis of symmetry. Okay. So if our coordinate pair for our vertex is equal to h and then k, h on the x-axis and k on the y-axis, our axis of symmetry must go through the vertical line that goes directly through that vertex that we found. To find the x-intercepts of a parabola, we let f of x equals 0 and solve for x. To find the y-intercept, we find f of 0. So we're going to see a very methodical process for determining the information that we need to graph a parabola. Before we do that, we want to make sure that we're ready to do that. We're going to solve each of these quadratic equations for x. Okay, so we're going to solve each of the following equations for x. Remember, if a squared equals a number, then a equals the positive or negative square root of that number. So that's a good reminder, because when we see x squared equals 9, to solve that, we're going to have to take the square root of both sides. So x squared equals 9. We're going to take the square root of both sides, but remember that that's going to give us a positive and negative answer. So we get x equals positive or negative 3. For the next one, we have the quantity x plus 2 squared equals 25. So we have x plus 2 squared equals 25. To solve for x, we're first going to take the square root of both sides. Remember, that's going to give us a positive and negative result for that square root. So we end up, the square root cancels the square, so we're left with x plus 2 equals positive or negative 5. We're going to subtract 2 from both sides. So we can think of this as x equals negative 2 plus 5 and x equals negative 2 minus 5. So we get two results. We get positive 3 and negative 7. For the last one, x minus 3 quantity squared minus 7 equals 9. We first need to do and move the 7 from the left-hand side to the right-hand side. So I do the opposite of subtracting 7, which is adding 7. And again, to keep my equation balanced, what I do on one side, I have to do on the other. So I end up getting x minus 3 quantity squared equals 16. Now I can take the square root of both sides. Again, that's going to give us a positive and negative result. This should make sense because if you think about it, oftentimes we'll end up with two x-intercepts where it intersects, the parabola intersects the x-axis. The only time that wouldn't happen is if the parabola never crosses the x-axis, so it's either above the x-axis and facing upwards or below the x-axis and facing downwards, but in that case it will end up having imaginary roots, and we'll see some examples of that as well. We end up on this one though, ending up getting x minus 3 equals positive or negative 4, so we're going to add 3 to both sides, and we get x equals, and we get two answers, x equals 3 plus 4, and x equals 3 minus 4. So we end up with 7 and negative 1 as our two answers for this one. Let's look at an example where we're going to graph a quadratic equation or function in vertex form. So I'm going to write vertex form, the general vertex form on the top. Remember that's f of x equals a times x minus h squared plus k. So we can get our h value and our k value for our vertex just by looking at the equation. So in this case, I can immediately identify that our vertex is equal to 1, 8. So I'm going to go ahead and plot that 1, 8, which means our axis of symmetry is equal to x equals 1. So that's our axis of symmetry. Now in this prompt, we're told to graph f of x equals negative 2 times the quantity x minus 1 squared plus 8. That's where we got our h and our k from. Plot the vertex and 4 additional points. So we've already plotted our vertex. We need to get 4 additional points, 2 on each side of the vertex. So that means we need to find 2 values to the left of x equals 1 and 2 values to the right of x equals 1. So my suggestions are going to be do 0, negative 1, 2, and 3. We're then told to identify the x and y intercepts and the axis of symmetry, which we've already done, the domain, and the range of this function. So essentially we're asked to do a lot. So we're going to do a lot. One thing I might suggest doing is finding our x and y intercepts next, because that'll give us potentially additional points that will give us these 2 points on each side of the vertex. So just remember, in order to find the y-intercept, we evaluate f of 0. So this is to get our y-intercept. Okay, so we just replace our x's with zeros in the function. So it's negative 2 times 0 minus 1 squared plus 8, which is equal to negative 2 times negative 1 squared plus 8. Negative 1 squared is positive 1. So negative 2 times positive 1 plus 8, which is negative 2 plus 8, which equals 6. So our first point that we found that isn't the vertex is the y-intercept, and that is at 0, 6. Now that should make sense because our leading coefficient here is negative. So our parabola is going to be facing downwards. So if our vertex is here and our next point is here, that should make sense because our parabola is going to face like a downward facing U. In order to find the x-intercepts, and there should be 2 of them in this case, we take our function negative 2x minus 1 squared plus 8, and we set that equal to 0. Okay, then we solve for x. So we have to undo all the things that are happening to x. The first thing I want to undo is the adding 8, so I'm going to subtract 8 from both sides. That gives us negative 2 times x minus 1 squared equals negative 8. Now we're going to divide both sides by negative 2, which will give us x minus 1 squared equals positive 4, because negative 8 divided by negative 2 is positive 4. We're going to take the square root of both sides. Remember, that gives us a positive and negative result, and the square cancels the square root. So that leads us to having x minus 1 equals plus or minus 2, since the square root of 4 is 2. Then we add 1 to both sides, which gives us our two answers for our x-intercept. X equals 1 plus 2, and x equals 1 minus 2. So that gives us x-intercepts of 3 and x-intercept of negative 1. It won't let me write it because I'm right in the corner. So let's plot those. Positive 3 and negative 1. Now here's the cool thing. We know the axis of symmetry is equal to x equals 1. So this function is symmetric around that line. So if I have a point at 0, 6, I will also have the mirror image of that point at 2, 6. So now I have 2 points on each side of the vertex. And I've gotten the x-intercepts and the y-intercepts. I can draw this parabola. I like to start at the vertex and go to the left and then go to the right and make sure it goes through my points and looks somewhat parabola-esque. All right, the last thing we need to do is identify the domain of this function, all the possible x values that it goes through. We've seen this in our first unit, looking at the domains and ranges of functions. This, because of the arrows and because it's a parabola, has a domain from negative infinity to infinity. The range, however, we have to think about where is it starting from in the x direction from negative infinity, which it goes down to negative infinity because of the arrows. And where does it go all the way up to? It stops at 8. So it goes from negative infinity to 8, and it includes 8, so we need a bracket. And that is how we graph a parabola in vertex form. Let's do another example just for good measure. Now notice on this one, the leading coefficient isn't there, so it's assumed that it's a 1, and so then it would be positive. So this is going to be an upwards facing parabola. Sometimes it's nice to determine that before you begin, just as a way to check your own work. We're going to identify our h and our k for our vertex. So our vertex is equal to the coordinate 2, 1. So I'm going to plot my vertex at 2, 1. And now we're going to plot some additional points. So the first point I'm going to look for is my y-intercept. To find that, we find f of 0. F of 0, we end up getting 0 minus 2 squared plus 1. That equals negative 2 squared plus 1, which equals 4 plus 1, which is 5. So our y-intercept is 0, 5. Now notice something. This parabola is facing upwards and its vertex is above the x-axis. So we can straight up determine right now there are no x-intercepts. They're imaginary. If I were to solve this, If I set this equation, if I set this function equal to 0 and solve, I'm going to get the square root of a negative number, which is imaginary. So let's see what happens, just so you know what to look for. X minus 2 squared plus 1 equals 0. Subtract 1 from both sides, and I get x minus 2 squared equals negative 1. When I take the square root of both sides, I'm going to get the plus or minus of the right-hand side, and the square cancels with the square root on the left-hand side. So we end up with x minus 2 equals plus or minus the square root of 1, negative 1. Now the square root of negative 1, I'm going to do a little aside over here. There's no number that can make that true. There's no number that I can multiply times itself and get a negative number. Because 1 times 1 is positive 1. Negative 1 times negative 1 equals positive 1. So this doesn't exist. This is imaginary. We call this I. This is the definition of imaginary numbers, I. The square root of negative 1 equals I. So we can say that we have x minus 2 equals plus or minus I for imaginary. Now I can add the 2 to both sides, and so we get that x equals 2 plus or minus I. Okay, I is not a variable, it is a number. It is an imaginary number. So this shows us that there are no x-intercepts because our answer is imaginary. So what I have to do then, because there are no x-intercepts for this problem, for this parabola, we actually need to solve for a few other points. Now, remember though, we can determine our axis of symmetry. Our axis of symmetry is going to be equal to x equals 2. Okay, so I have this axis of symmetry, so I can already plot one of these other points. Because if I know that I have 0, 5, which is 2 points away from our axis of symmetry to the left, I would also have the point 2 points away from the axis of symmetry to the right at that same y value. So we automatically can get that 4, 5 coordinate. Now what I can do is I can actually just substitute a couple values in, or I can just do f of 1, because 1 is between 0 and 2, and solve for that. See if I get a nice result. Even if I don't, I can plot it approximately and then get the mirror image on the other side to get our other 2 points. So f of 1 is going to be equal to 1 minus 2 squared plus 1, which is equal to negative 1 squared plus 1, which is equal to 1 plus 1, which is equal to 2. So I end up getting the point 1, 2, and then the mirror image of that would be 3, 2. So I've taken care of my 2 points of each side. I've taken care of my y-intercept. I've taken care of my axis of symmetry. I can now draw my parabola. I'm going to start from the vertex and go upwards on the left, upwards on the right. I know because it's a parabola, my domain is from negative infinity to infinity, which is all the real x values. My range, looking upwards to the y, starting from negative infinity, where's the first point that I see? That's at that vertex, which is at the y value of 1, and it goes upwards to infinity. Now it includes that value of 1, so we use brackets on the left-hand side when representing this range. In part 2 of this video, we're going to take a look at when we have quadratics written in standard form. How do we determine our axis of symmetry? How do we determine our vertex? So we'll take a look at that. Thank you very much.